Any questions on homework assignments? Any questions on the review you guys want to go through? Or you guys just all really good? I got it.
Well, I'm just working on homework. I don't know if I need help with this question.
Casey and I were going to ask you about 53 yesterday.
53 on 5.7?
5.6.
6. Sure, let's do 53. What's 53 say?
Y equals 2x arc cosine x times 2 the square root of 1 minus x squared.
Okay, what are we doing?
Says find the derivative.
Okay, let's do it. Anything else? Just derivative?
Yeah.
So we're taking the derivative with respect to x of the function 2x arc cosine of x minus 2 square root of 1 minus x squared. Now, for this problem, I'm going to break this up into two pieces. I see a subtraction sign that tells me that I can treat this as two separate derivatives, the left-hand piece as one derivative, and the right-hand piece as a second. So let's do it one piece at a time. Let's look at piece number 1. 2x arc cosine of x. To determine the derivative of that function, I have to first recognize it as a product. So I'm going to apply the product rule. So number 1. So in order to do the product rule, I need 4 things in total. I need to know what the left piece is, what the right piece is, what the derivative of the left piece is, and what the derivative of the right piece is. So let's identify the two we know, left and the right. Left is 2x, the right arc cosine of x. And the derivatives. The derivative of 2x is 2. The derivative of arc cosine is 1 over the square root of 1 minus x squared. Or is it negative? I think it's negative. Again, GG tuple. So with those pieces, I can now successfully take the derivative. Let's talk about that first piece. First piece derivative is left 2x d right, so times negative 1 over the square root of 1 minus x squared, plus right d left. So right is arc cosine of x, d left is 2. So I end up with that as my left-hand piece. That is my derivative of part 1. Then I subtract the derivative of part 2. So go over to my right-hand piece. On my right-hand piece, number 2, I see that it is not a product. It is a power with a chain inside of it. So I come over here. To do the derivative of a chain rule, as a reminder, I have f of g of x. In this case, my f function is the square root function. My g function is the 1 minus x squared function. So f prime, the derivative of the outer function, is 1 over 2 square root. I've done those so many times I have that one memorized. Otherwise, you turn it into a power to the 1/2 power, and then you take the derivative of that function, and you get the same solution. The derivative of 1 minus x squared, g prime, is negative 2x. So we take the derivative of this function. The derivative of a chain, as we recall, is f prime of g times g prime. So let's take those pieces. The derivative of the second piece. So I have negative. The 2 is a constant. I'm going to pull it out front. Times f prime of g. So f prime is 1 over 2 square root of g. My g is 1 minus x squared. times g prime. Now g prime is negative 2x. So there's my derivative. Now I just simplify what I can, and I should be done. So from here, let's see. On my first piece, I can move this 2x to the top. I can move the 2 out front. It becomes a negative, so this becomes negative 2x over the square root of 1 minus x squared plus 2 arc cosine of x. So the simplified version of the first piece minus, all right, now I gotta do some fanciness here. Let's see, this 2 and that 2 cancel. This negative and that negative become positive, so this becomes plus. The 2 moves to the top, and I end up with 2x on top over the square root of 1 minus x squared on bottom. From here, I can see I have a negative 2x over the square root of x, or 1 minus x squared, and a positive 2x over the square root of x minus squared. So those two cancel, which means derived derivative should be 2 arc cosine of x. Oh, nice. That worked out very nicely. Verify with the back of the book, please. The only thing I'm not 100% certain on is my derivative of arc cosine. Again, I use GG for that too. I don't have that one memorized.
2 arc cosine.
Man, I'm good. Woohoo! Okay, that was number 53. Any other questions?
17 on 5-7.
17 on 5-7. Are we?
I'm gonna have
Would you mind taking a picture of it for? Yeah, just in case. I mean, it's in the video, but you know. Good. Michael? And feel free to share that to the Google Classroom. All right, Michael. What's number 17 say from section 5.7?
Integral of x cubed over x squared plus 1.
dx?
Yes.
Okay. So, I look at this function, and my first thought when I look at it is I look for a chain rule, because it looks like I might have a piece that has a derivative. Unfortunately, that doesn't really work here, because my chain rule problem has the wrong pieces in it. If I wanted to use the chain rule, the x cubed would need to be on the bottom, and then it would become a natural logarithmic function. Because if I take the derivative of x cubed, I get x squared, which there is an x squared in the problem, but it's in the bottom of the denominator, not the top of the denominator. So that leads me to tell that I should probably not do that. So instead, I'm going to look specifically at just this bottom piece, and that is actually one of our arc functions. I believe that is arctangent. So I go to my arctangent list. Pull out my cheat sheet. Woo! Arctangent. Let's see if I was right first. Hey, got it. All right. If I go over here,
Sometimes.
the arctangent function says the integral of u prime over a squared plus u squared du is equal to 1 over a arctan of u over a plus c. So I'm going to attempt to force it to be in this form. And when I do, there may be some small consequence to this, so I got to be careful. But let's see what happens. So if I'm going to do this, let's identify my components. So in this case, my a is going to be 1. My u is going to be
I need
x.
the following students to the office: Miguel Chavali, Isabel Rose, Alejandro Martinez, Dan Grissom, Tristan Bell, to the office.
Unfortunately, if I choose as my a and my u, you might notice there's a problem. I don't actually fix anything. Nothing actually gets better. If I do this as my a and my u, then this becomes, quite simply, Well, first let's go ahead and do du. And my u prime would be just 1. So this just ends up becoming the integral of u cubed over u squared plus 1 du. That's not better in any conceivable way. So let's instead kind of try to do an alternative. See if I can make this work with some other technique. So maybe I try. I know what I gotta try. I can feel it coming. Long division. So I tried to use arc cosine, but arc cosine in this form simply does not work. So I'm going to now attempt to do long division instead. In order to do long division, though, I have to take the top piece and divide it by the bottom piece. So let's do it. I take the division of x cubed, and I divide it by x squared plus 1. Now remember, this is not supposed to work out nicely. It's supposed to have some remainder in it. That's the goal, okay? Always keep that in mind, that is the goal of these kinds of problems. So let's try to divide this. To divide this, I need to figure out what takes x squared, turns it into x cubed. Well, that's just x. If I have x there, then this becomes x cubed plus x. I then subtract that piece from the original piece. Give me a new version of the problem, which is negative x. Now, x squared never goes into negative x. So that means this integral becomes as follows. The integral of x minus x over x squared plus 1 dx. As a reminder, when you do this, the top piece is its own function. The remainder is left inside the original function. So, we now left with this. This, I actually don't need to do an arc cosine for. I can do a straight u substitution for. So let me do that. Number 17. After doing some long division, I end up with this version of the problem. And now I make my u equal to x squared plus 1. I make my du equal to 2x dx. I split this integral into two parts. This becomes the integral of x dx minus the integral of x over x squared plus 1 dx. If I notice in this problem, I have an x dx, not a 2x dx, so I divide the 2 over. This becomes 1/2 du is equal to x dx. There's my x dx, so that tells me I'm in a good spot. I make my u substitution with the right-hand piece. The left-hand piece, I just apply a general integration rule, applying with the power rule. So, integrate x dx minus, okay, this becomes, on top, I have a 1/2, which I'm going to move up front. The x dx becomes du, and on bottom I end up with just u. Give me that version of the problem now. And now I integrate each piece. Notice the left-hand piece I did not put in terms of u because I don't have to. I can integrate with its own rule. So left-hand piece becomes 1/2 x squared minus 1/2. The integral of 1 over u du is ln, absolute value of u, and plus c. I don't want u in my problem. I want x in my problem, so I do a final substitution. This gives me 1/2 x squared minus 1/2 ln, absolute value, x squared plus 1 plus c. The absolute value symbol in this problem is not necessary because it's x squared plus 1 and is always positive. So the alternative version of this problem and the solution in the back of the book, 1/2 x squared minus 1/2 ln of x squared plus 1 plus c. No problem. Yeah, had a little trick to it.
Thought about long division. Didn't do it.
Long division was also introduced in this chapter.
Oh, yeah. Close.
Other questions? I noticed that even though this section was about arc cosine, there was not an arc cosine problem in this. Let's use long division.
On 6156,
Yeah.
it's the derivative. There's arctan of x.
Okay.
And then you, if it's plus 1 plus x over 1 plus x squared, which is the quotient we're on back.
Okay. Let me see what's the problem again.
Arctan of x plus x over 1 plus x squared.
And yes, the left-hand piece, we just apply the rule directly. The right-hand piece, we have to do a quotient rule. So this one, this would become 1 over 1 plus x squared plus quotient rule, low d high minus high d low. And I believe the back of the book gives a very unique answer to this one. And so you end up with 1 over 1 plus x squared plus negative x squared plus 1. The back of the book, I believe, joins these two fractions together. So they would take one additional step. They would take this left-hand piece and multiply it by 1 plus x squared on the top and bottom. And so on top, you end up with 1 plus x squared plus 1 minus x squared all over 1 plus x squared squared. And so you end up with 2 over 1 plus x squared squared.
Will the AP test prefer that answer or prefer the top
If it was multiple choice,
one? It'd be that one.
it'd be that one. If it's free response, the top one is okay. Usually, if they want it to be like the other one, it'll say in the problem, simplify completely. That phrase indicates you need to keep going until every algebraic rule has been exhausted. Those are very rare by comparison. Okay, so you're going to look for those. But most of the time, that top answer would be like, oh yeah, that's fine. And even if it's simplified completely, that's like 1 point off out of a 10-point problem. Maybe 2. And so you want to balance. The AP exam is a lot of a balancing act, right? It's a lot of problems. You have a certain amount of time to do it. You want to prioritize and be like, okay, is this going to be worth 2 points, or is it better for me to go on the next problem and get 8 more points because I got that problem into my time on it? I'd always say it's worth more time and better use time. Okay, other questions? No more? From any part of the section? Any questions?
equation like it's going to be find the derivative and then you plug it in.
Mm-hmm. Don't forget, as we'll talk about this again over the next couple weeks, secant line also exists, which is a perpendicular and tangent line. It's the same process. Goes to the same textures at the end. You have to convert the slope into something else. The negative reciprocal.
How do we get the integrals again with this one? It's like the integral from like 1 to 4.
Okay. Then what is it?
Huh?
What is it?
X in 21, this is integral of 1 to 4. So 2x plus 1 over 2x dx. And this is on the review.
Okay. So for this problem, I'd probably split this into two fractions. First of all, but once you have it set so you can actually take a derivative, as a reminder, you'll end up with what we call capital F, right? The parent function, the bigger function. And you have to plug in the boundaries between 1 and 4. What that means is you plug 4 into that function, and plug 1 in, and drop it. Yes. It's also first one of the theorem practice. So you first integrate, then you plug in the top one, plug in the bottom one, and subtract the results. Other questions? Michael gestures right up when you guys speak.
Trying to think.
What?
I need to sleep hard.
Sleep is for the weak. You shall sleep when you are dead, sir.
I guess it's
Or should you call it sleep while you're alive, too? Mildly important.
In proof of differentiation, you have one where it's like use the y diagonal. Times like the y and the x both in them.
Yes. Michael, I'm enjoying your escapade. What you do?
25.57.
Okay.
Already. No, I was doing 23. Oh. Crap. Oh, now I know. Now I want to know how 23 works. I split it into two integrals. I solved for one of them. I solved for the 5 over that crap.
The other one, foil it through, and then do a U substitution.
I was thinking that, but also I didn't want to go through all that work just for it to fail. It's like, I don't want to do so much work and then
It should be negative x squared plus 6x.
Yeah.
On the bottom.
You know, it's not even. I don't do that with the same job as what I'm just tired. No, I don't know. I like people taking the square ones. Never did. I don't think I've done.
I enjoyed taking square pegging.
I think I would have enjoyed it more if it wasn't always prefaced with the fact that, oh yeah, this is like the worst way to do this, so you don't ever have to do this, just use the quadratic formula.
Yeah, that's true. What you want to do is stop algebra. Yeah. When you go to type this, it's like, oh yeah, this won't work unless you can do it. Sadly, a lot of algebra is that way, where it's like, this is not useful. And then calculus is like, hey, I think it wasn't useful. Dude, totally useful. Hope you remember. Sleep.
See, I'm confused how you get the Mike 10.
I think it was made a mistake. So I'm checking it back. There's something to talk about this. When I looked at it, I was like, this is my time problem. Yeah, okay, I was right. Sweet. Alright. So for this problem, what I do is I make a U substitution. And the problem with I do a U substitution here is that the top never goes away. So what I have to do then is back solve for x using u. This means that this is u minus 3 equals x. And so this integral becomes 2u minus 3 all over x plus 3 squared plus 4. Oh wait, wouldn't be x plus 3 squared anymore, it'd be u squared plus 4 du. And then I split this into two integrals. This becomes the integral of 2u over u squared plus 4 minus the integral 3 over u squared plus 4. left-hand piece, I do a second substitution. In this case, like let's call it W, is u squared plus 4. So that means my dw and dw is 2u du. I have 2u du in the problem. Don't be lazy, write the u's. So then this first integral becomes the integral of 1 over w dw, which makes this the natural log of the absolute value of w minus, I pull the 3 out, and then this one's an arctan function. So this becomes minus 3 times 1 over a, so 1 over 2 arctan of u over 2 plus c. This becomes negative 3 halves arctan of u over 2 plus c. W, as we just said, is u squared plus 4, so this becomes the natural log absolute value of u squared plus 4 minus 3 over 2 arctan of u over 2 plus c. And u, as you recall, is x minus 3, or sorry, x plus 3. This becomes ln absolute value of x plus 3 squared plus 4 minus 3 over 2 arctan of x plus 3 over 2 plus c. Step one. Required a double substitution in order to get it to work. We don't often get to use dw, mainly because darkening duck was kind of a 90s thing. dw. Darkwing Duck. Alright, 10 minutes left. Even one.
The integral of dx over the square root of 9 minus x squared.
Okay, so first I have to identify which of these I think it is. This to me looks like arc sine.
Yeah.
So, the arc sine formula of u over a plus c. So I know this is what my solution is going to look like. I just need to figure out what my two pieces are, u and a. So my u, as a reminder, the original function, the integral, should look like the integral of u prime over the square root of a squared minus u squared du. Well, we see a lot of similarities. Let's talk about each one. So first, u. We have to get u right because the u affects the other two pieces. So that's the easy one. In the original problem, it's x squared. We want u squared, so let's just make u equal x. Well, then what's my du and u prime? Well, du would just be dx, and u prime would just be 1. That's relatively straightforward. Okay, so then what's my a? Now notice in the original formula, it's a squared. So my a has to be 3. So then I just plug everything in. This integral is equal to 1 over a, so 1 over 3.
Oh, it's not 1 over a for arcsine. It's just arcsine of u over a plus the arctangent is 1 over a.
That's so weird. I remember the 1 over a being all 3 of them. That is so weird. Okay.
So it's just kind of secret to you.
That is
Not
all
enough.
sneaky. Sneaky.
Crazy boy.
Okay. I could have sworn. Alright. It's a good thing you checked. Thank you. Otherwise, I would have checked the back and been like, what? Okay. Alright, so my actual solution should be arc sine of u over a, so that'd be x over 3 plus it. That was the best sine ever. Arc sun. There you go. I could have swore. No. Isn't it bad? So again, it's about figuring out my u so I can plug into the formula. If I can figure out the u, the rest is not so good. Notice how I had to prioritize correctly. I don't want to figure out a first, I want to figure out u first because that could affect my other pieces and move things around. What I find interesting is if you go backwards, what happens? Want to see for a quick second? What if I took the derivative of this function? Well, then I'd pull out my arc sine rules and do the derivative, right? What's the arc sine rule say? This is equal to plus or minus.
Minus. U squared.
So that would be x over 3 squared, right? Those two don't look the same. So what happened? Well, that's pretty easy to figure out. This becomes 1 over square root of 1 minus x squared over 9. And then pull the 9 out. And when you pull the 9 out, it ends up causing the other side to become 9. Which is kind of neat. I think that's kind of cool. You know. Man, I still swear I had 1 over 8. I feel like it should. No. I guess get to have some fun with it. Why is arc sine the only one that does not have 1 over 8? Oh, now I remember why. See? There's a chain rule. I have to multiply this by the derivative of the inside, right? The derivative of x over 3 is 1/3. This 1/3 ends up causing a 3 to appear in the denominator out here. So 1 over 3 square root. The other way to think about this is move the 3 inside and see what happens. If I want to move the 3 inside, I have to make them both the same. So this would become 1 over the square root of 9 times the square root of 1 minus x squared over 9. And then when I distribute that through, this becomes 1 over the square root of 9 minus, and then 9 times 1 over 9, just leave us as the x squared. I forgot to do the chain rule. No, Douglas, no. How could you? You have failed.
You have failed the six.
And that's why there's no 1 over a as well. That's the use substitution fix. I know the use substitution does not fix it. Last chance. Got about 3 minutes left. Any question?
Yeah, I've got to shut off. Okay, just do 29 on 7. It's the integral from negative half of x over square root of 1 minus x squared. Pretty sure.
Use substitution.
Use substitution.
Of w dx. W dx. So I have x dx right there. I have x dx right there. So I start replacing. Integral. So on top, the x dx becomes just negative 1/2 du. On top, we get that. On bottom, we get square root of u. And then I'm going to go ahead and affect my boundaries now. If I plug in 0, I get 1. If I plug in negative 1/2, I get 3/4. Okay, now I integrate. As a reminder, this would simply be negative 1/2 integral of u to negative 1/2 power du. Just algebraically rewriting it. And then I integrate this function, again, from 3 to 4. When I integrate, I have negative 1/2 out front. The integral, I would add 1 to the power and then divide by the new power. So u becomes u to the 1/2, divide by the new power, which is positive 1/2, and then plus c. But we're not doing an indefinite, so we have to plug in 3/4 and 1. Now, 1/2, 1/2 are going to cancel. Negative is going to stay. So we end up with the following. Negative square root of u 3/4 and 1. So I plug in and I finish. This becomes negative square root of 1 minus negative square root of 3/4. And whatever that is my solution.
I got locked in my behind identity.
It should be
Daniel, may I see to the office,
It
please?
looked a lot like the
square root of 3 minus 1 over 2. That's my solution.
You?